Okay, let's take a look at example number 9. Okay, if we have the function f of x equals x squared minus x plus 2, how close to 2 does x have to be to ensure that the function f of x is within a distance of 0.1 of the number 4? Okay, so again, we're saying how close to 2 does x have to be to ensure that the function is within a distance of 0.1 of the number 4. So here is 2 on the x-axis. Okay, and here is the value of 4. So that is our order pair 2, 4. Okay, so we're looking at these values here. So if the distance from the function f of x to 4 is less than 0.01, then f of x lies between 3.9 and 4.1. So above 4 is the value of 4.1, and we create a horizontal line because that's within a distance of 0.1 above the value of 4. And then below 4, again, within a distance of 0.1, so 4 minus 0.1 gives you 3.9. So now what we've done is we created these two horizontal lines. Okay? And so what we're saying here is that we have this function x squared minus x plus 2. And we're saying that it's going to be in between these two numbers, 3.9 and 4.1, because again, it's within a distance of the number 4. Now we need to determine the values of x such that the curve y equals x squared minus x plus 2 lies in between those two horizontal lines, y equals 3.9 and y equals 4.1. Now we graph the curve, okay, and lines near the point 2, 4 in that figure. And then with the cursor, we can estimate that the x-coordinate of the point of intersection of the line y equals 3.9 and the curve y equals x squared minus x plus 2 is about 1.966. Okay, and then similarly, the curve intersects the line of y equals 4.1 when x is approximately 2.003. So let's take a look at that on our graphing calculator. Okay, so we're going to put in the function x squared minus x plus 2. Okay, and then we're going to create our lines. So we got y is equal to 4.1. That's our horizontal line above that point. And then the horizontal line below that is 3.9. And then we also want to create a window so that we can see what's happening, because if we graph this right now, we don't get that clear of a picture. So now we got to use our windows and use our rectangles. Okay, so the values of x go from 1.8 to 2.2. And again, so that we can see that within our viewing rectangles. And then our y minimum, y max is 3.7 and then 4.3. So again, just enough for us to be able to see what's happening. Okay, so now we're going to go ahead and hit the trace button. Okay, so if we, if we go down here, and what happens at the value of 3.9, what is the value for x? Well, we can see that, and I'll go ahead and copy that here by using our trace button. And then let's do the other horizontal line, and then go to the right here. And we can see that the point of intersection there is 2.032. Okay, so what we've determined here is that this is the value of x here, and this is the value of x here at those particular points. So we can say that 3.9, or the function x squared minus x plus 2, is in between these two numbers when the values of x are in between what two numbers? Well, we just determined that. One of them is 1.97 on the left, and the other one is 2.03. And so therefore, this function now is within the distance of 0.1 of 4 when x is within a distance of 0.03 of 2. And so, just so you know, we can also use Desmos to locate these particular values. So let's just go ahead and do that here. We're going to go ahead and put in the function. So we have x squared minus x plus 2. And then we know that we have one value that's y is equal to 3.9. Let's go ahead and put that in there, y is equal to 3.9. And then we also know that y is equal to 4.1. Okay, then we can zoom in a little further. Okay, so again, if we look at that point, there's 1.96. And then this point represents 2.033.